Alright, you guys, we're going to finish off this section looking at numbers 23 and 25. We are not going to do 27. If you want to attempt 27 on your own, go for it. It is an extra challenge. I don't have a video for it. You're not required to do it. It's if you are feeling extra ambitious and you want to go for it. Anyways, so we're going to start with 23. So this is the same section where we're solving these conditional trig equations. So for number 23, we have cosine of 2x minus cosine x equal to 0. So the first thing we have to do here is decide which of our double angle identities we want to use. So that's why it's important for you guys to know all three of the possible identities for cosine of 2x. Granted, you can derive the other ones using your Pythagorean identity of sine squared plus cosine squared is equal to 1. So as long as you know one of your trig identities, I would say, or one of the double angle identities, cosine squared minus sine squared, would probably be a good one to know. You can derive the other ones, but it is useful just to have them all memorized just so you have them in your back pocket ready to go. Because for this particular problem, I don't think that using cosine squared minus sine squared is our best route. I think we want to keep everything in terms of cosine if possible. So keeping that in mind, cosine of 2x, we could say is the same thing as 2 cosine of x minus 1. So for this first step, what I've done is I've replaced that cosine of 2x with 2 cosine squared x minus 1, and then that minus cosine x is just coming down again. Because at this point, we now have something that we can factor. So I've rewritten it with the order that we would expect to factor something. So we have 2 cosine squared x minus cosine x minus 1 is equal to 0. So at this point, that's something you can factor, so I'll give you a second, and you can factor that. Or you can pause it. I suppose that would be probably better. So you pause it when you're ready, keep going. So once it's factored, that is 2 cosine x plus 1 times cosine x minus 1 equal to 0. So you can set both of those parentheses equal to 0. So we have 2 cosine x plus 1 equal to 0, cosine x minus 1 equal to 0. And we go through and solve. So we have that cosine of x is equal to negative 1/2, cosine of x is equal to 1. Looking at our unit circle, where is that true? We have 0, and I guess probably not technically 2 pi, probably shouldn't have included that since 2 pi was parentheses. But so 0, 2 pi over 3, and 4 pi over 3. Those would be our answers then for number 23. So you guys can stop there, try number 25 on your own, come back if you have questions on number 25. So number 25, we have sine of 4x is equal to negative 2 sine of 2x. So we are going to go ahead and use our double angle identity on the first side with sine of 4x, recognizing that sine of 4x is the same thing as sine of 2 times 2x. So we pull out our 2 sine of 2x cosine 2x is equal to negative 2 sine 2x. And it might be tempting to say, I'm going to just keep going, I'm going to keep going, I'm going to keep expanding things out using my double angle identities, but you don't have to do that. At this point, what I would do is I would move my negative 2 sine of 2x over to the other side. So I would have 2 sine of 2x cosine 2x plus 2 sine of 2x is equal to 0, because at this point, now I can factor out a 2 sine of 2x. So, factoring out my 2 sine of 2x, I'm left with cosine of 2x plus 1 equal to 0. So then again, we'll set both of these things equal to 0, sine of 2x equal, or 2 sine 2x equal to 0, cosine of 2x plus 1 equal to 0. So if I do that, 2 sine of 2x equal to 0, cosine 2x plus, 2x plus 1 equal to 0. At this point, then I can say that over here, for my sine of 2 sine 2x equal to 0, 2x would then be equal to 0 and pi. That's where we have sine of x equal to 0. But remember, we were going around the circle 2 times because it's 2 sine of 2x. So 0, pi, 2 pi, and 3 pi would be when sine of x is equal to 0. And then cosine of 2x equal to negative 1. So we'd say when is cosine equal to negative 1. Cosine is equal to negative 1 at pi. But again, it's 2x, so we're going around the circle another time. So then we have pi and 3 pi. So you notice our answers actually overlap over here. So 0 pi, 2 pi, 3 pi, and over here we have pi and 3 pi. So again, we're not done because that would be 2x is equal to those. So we go through, we divide by 2, and we end up with x is equal to 0, pi over 2, pi, and 3 pi over 2. So that is 23 and 25. And so it's a little bit longer. Let me know if you have any questions.